Hello and welcome back to Data Visualization using Python. In today's video, the first of section 4, we're going to start at looking at how to better tell stories using data visualization. Data visualizations are all ultimately about conveying information to the viewer, and importantly, this information is a story, a kind of explanation about the numbers that the data set contains. In this section, we're going to see how to use a number of different tools to improve the way these stories flow. Essentially, to improve our writing skills. In this section, the things we're going to be using to improve our writing skills, so to speak, are looking at making pretty aesthetically pleasing plots, using color theory and how the human eye perceives colors, to use those to better convey the information that our plots contain, and how to use annotations to bring the viewer's eye directly at the information that we want them to see. Today's video is going to focus mainly on plot aesthetics. In this video, we're going to see how to quickly change the look of multiple attributes of our plots using Matplotlib's built-in style sheets. We're going to see how to use Latex to annotate mathematical text, how to change font properties, and finally how to tweak the legend for plots that contain legends. Let's dive right in. So as usual, we're going to import pandas, NumPy, and Matplotlib, but this time we're actually going to generate some random fresh data. We're not going to be working with a real data set, we're going to be working with some randomized data, since what we mostly want to see here is the appearance tools that Matplotlib provides. So let's generate 3 sets of 1,000 random numbers and a 512 squared smoothed Gaussian random field. So Matplotlib contains a number of style sheets. These style sheets are a way of changing all kinds of attributes of the plot, from the color maps used to the fonts, the background, etc. We can see which different styles Matplotlib provides by using the plot.style.available list. And you can see this is a list of Unicode strings that contain a number of different style sheets. As you might imagine, classic here is our default. So let's take a look at what some of these other style sheets look like for us. Let's make, using our data set here, a couple of different example plots. A plot with points in a line, a scatter plot, colored, a image plot, and a bar chart here. Now, we could go in and change the individual attributes of each of these plots, the colors, the line styles, fonts, backgrounds, etc. But to do that for a wide variety of plots like that, we'd have to use multiple lines of code for each individual plot here. It'd be a lot of work, in other words. With these style sheets, you can build your own style sheets or use the built-in Matplotlib style sheets to change everything at once. In other words, to change all of the default plotting choices that Matplotlib uses. So, for example, we can change the colors here to use only grayscale colors. So, if I call plot.style.use here, I can pass grayscale as my color map. And here you can see I'm given a gray background and all of my colors are removed. In other words, everything is still visible, the differences, but nothing here uses colors. So if I was producing plots that I wanted to be able to print in black and white, by simply using the grayscale color map, I can automatically get a figure that will print out nicely on a black and white option. So as you can see, there's a huge variety here. So if you're an R user and you're used to using ggplot, you can make your plots look like ggplot. And here you can see I've changed the color maps here I've changed the fonts, and I've added a grid. So play around with these style sheets and choose one that you think works well with your aesthetic. If you don't find one that works well with your aesthetic, you can actually begin to modify and create your own style sheets as well. Let's take a look now at labels. So you can see we're still using this ggplot style, and I've applied two labels here, an x-axis label and a y-axis label, because here I'm showing a histogram of x and x squared. Now, what if I don't want this to have this caret symbol? What if I want this to actually look like a superscript? Well, matplotlib actually very nicely can do all of its text in LaTeX format. So if you're familiar with the LaTeX language, it's a typesetting language that includes very, very robust features for doing mathematical text. So if I bracket this in $signs for the LaTeX mathematical mode, you can see I actually get a nice x squared here. And you can provide any of the commands that LaTeX is normally providing for you. So I can do all of the fancy symbols and extra characters that LaTeX provides here, and it'll automatically render that for you. Literally any mathematical symbol you can think of, LaTeX can provide it for you. In addition to that, you can also change the font properties. So say, for example, I want my labels here to be much larger. Well, I can do that using the RC params. And this is really a way of accessing all of the different configuration options matplotlib provides. If you're interested in diving in deep, take a look at some of the documentation for RC params. But RC params here can actually change nearly anything. So, for example, if I want to change the font size, I can do that simply by changing the font.size attribute. So let's make this font much bigger. Let's make it 32. And here you can see I now get absolutely massive, just absolute unit fonts. Now you might not want to actually do that. You might want to revert back to normal. So be aware that once you've changed things in RC params, they are changed for the rest of your session. So let's revert this back to something a little more normal. So there's our 12-point fonts again. Let's now bring up a legend and take a look at what we can do with that legend in terms of changing its appearance. So the first thing you'll notice if I bring up a legend is where that legend actually ends up. And here you can see that the legend has actually been placed in the upper right-hand corner. And this is actually covering up a lot of our data. So we can shift this around by giving the location keyword argument. So if I say left, you can see it actually gives me a list as a warning of the default locations. Now left is actually not one of these locations. It's falling back on best. So what I might want would be upper left, which will put it in the upper left, or alternatively lower left. Now that best that it falls back on is actually a cool default to use. Best will actually place it in the location that covers up the smallest amount of the data that you're actually providing. So by default, if you're adding a legend, it's often good default to giving it a location of best. Now there's another option if you really want your legend to be placed in the upper right hand corner, but you still want to be able to see your data. You can actually make the background of the legend transparent. So by using alpha, which is essentially the transparency, so let's set our frame alpha here to 0.5. And here you can see now our frame is actually partially transparent, and we can see the data behind it.